Hey everybody, remember our good old friend the unit circle. Okay, notice we're going to go through this unit circle. Remember, pi 6, 30 degrees. Here's right in the middle, pi 4ths, that's 45 degrees. Pi 3rds, which is what? Every time I go every 30 degrees, 60, 90, 120, 150, and so on. Every pi 6 is 30 degrees. Every pi 3rds is 60 degrees. What's 1/3 of a pi? 1/3 of 180, and so on. Remember, we need to get back into cosine, sine, but let's function on sine. Notice, sine is basically what? The length on the unit circle of the y component. Okay? Notice, we're going to make a graph. Let me just show you real quick. Sine of pi 6 or 30 degrees is 0.5 or 1/2. Let's try to remember these values. Pi 4ths is square root of 2 over 2, that's sine. That's 0.707, 0.71. And pi 3rds, or 60 degrees, is the square root of 3 over 2. That's the sine of pi 3rds, or 0.866. So these are all the values you need to know, either cosine or sine. 1/2 root 2 over 2, root 3 over 2. This is for sine. Pi 6, 0.5. Pi 4, 0.707. Pi 3rds, 0.866. And then pi halves, or 90 degrees, is 1. Okay? All right, let's take a look at that unit circle again. So the y component of this 30, 60, 90, pi 6 triangle is 0.5. Notice how much it jumps here, because when we graph this, it's not going to be linear. I go 30 degrees, I go from 0 here. Sine at 0, or 2 pi, sine is 0. Okay? And in just 30 degrees, I go up 0.5. So it jumps a lot. And then I go another 30 degrees, and it goes from 0.5 to 0.7, root 2, we go from 30 degrees, let's go stop at 45, root 2 over 2, or 0.707. So it jumps up 0.21 roughly. And then I go up to 60 degrees, or pi 3rds, and it's 0.866. So it only jumped 0.16 there, or 0.15 really. Okay? So as I go up around here, there's not a lot of change in the y. 1 second. Okay, sorry about that. I had a break. I had a student come in. All right. So notice I'm going up. There's a lot of change relatively quickly here as I go 30 to 45. But right about here, notice the height of these triangles, my y component, isn't really changing much. I go from 60 degrees, or pi 3rds, at 0.866 is my sine value, to its max value at pi halves of 1. I don't know if you can see that or not, it's where the glare is. So here's pi halves, and that's 1. And then over here I go 30 degrees, and I just move minus, now it's down to 0.866 again, 0.707, 0.50, and now we get in negative territory as we go through a whole period of the unit circle from 0 to 2 pi. Negative 1/2, negative 0.707, negative 0.866. So we're going to go through all these values. I want to show you what we're going to graph them on. Okay? Let's make this value 1 here. So this would be 0.5. And we're going to go all the way to 2 pi. So here's half a pi. So here would be, remember, here would be 30. Here's 40. Let me see. Figure this out. Here's pi halves. And here's pi, 3 pi halves, and 2 pi. So right in the middle, here is pi 4ths. Okay? So if this is, let's say this is 0.5, let's make this 1. So here's 0.5 right here. I don't know if you can see that. So at 30 degrees, it's about right here, I'm about 0.5, 0.7, and at 2 pi thirds, I'm 0.866, and then right here pi halves, I'm 1. And what am I at 0? I'm at 0, so as we graph these values, okay, and then I come back, I'm 0 here again. We're going to have values, again, I'm going to go point at 2 pi thirds, 0.866, at pi halves, 0.7, 0.5, and 0. And then we get down to negative trend, where the bottom's out here. At 3 pi halves, it's negative 1. But as we go around in 30-degree increments, negative 0.5, negative 0.707, right at 45, sorry, we go around the unit circle I'm at, 5 pi fourths, 45 degrees past 180 there, it's 0.7, and then I get down to 4 pi thirds, it's 0.866 negative. These are all negative, and I finally come down, and we're going to graph this graph tomorrow. So we're going to graph all these values, and this is where your function looks like. Okay? Oops, I went a little high here. That's a sine function. And notice cosine is going to be different. Cosine is 1 here, and 0 at pi halves. Okay? And then it's at pi, cosine is negative 1. And again, it's 0. So there's your cosine function in blue. So that's what we're going to go over tomorrow, is graphing sine. But notice, that was in black. It's my last thing, guys. It should be done. Sine of theta, like I said, the max value is 1 to negative 1. Okay? We'll learn about our amplitude. I'll be done in a second, sir.
Okay.
Amplitude is going to be my max value minus my min value divided by 2. That's what's called an amplitude. How high I go and how low I go divided by 2. So I go from 1 and negative 1, 1 minus negative 1, and divide that by 2. And that's all under absolute value. Don't worry about that for right now, but that's going to be my amplitude is 1. So I've got 1 minus negative 1. Here's my, so 1 minus negative 1. This is all of the absolute value is 2 divided by 2. My amplitude is 1. It goes up 1 and down 1. Okay? But what if I did it times this by 4? This will change my amplitude. What if I made it 4 sine theta? So now instead of being a max of 1, it's going to be up here. I'm going to graph this in red. Hope you can see it. My sine curve is going to go way up to 1, 2, 3, 4. It's going to max out there. It's still going to be 0 at pi. It's going to go down to negative 4, down here at negative 3 halves right here, and back up. So I'm changing the amplitude by, instead of being a sine of pi halves being 1, 4 times 1 is 4. Okay? So that's kind of what we're going to cover tomorrow. We ought to be able to graph a sine function and then change it by changing the amplitude. And later on we'll get more involved, okay? As far as shifting them like we do parabolas, okay? All right, that's all I have. Just be ready to review your unit circle. Know your values of cosine, sine for all the reference angles. Pi 6, pi fourths, and pi thirds. That's 30, 45, and 60. Those are all your special right triangles, okay? All right, that's it. Thank you.